As promised, I have come up with Matlab examples for inverse trigonometric functions as well as hyperbolic trigonometric functions. So let us see how they look like. First, let us look at the inverse functions. This is the code to plot the inverse functions. So you can see this is arc sine x, arc sine x, arc cos x, uh, arc tan x, uh, arc cosec, arc sec, and arc cot. Okay, so this is the code for MATLAB code for inverse functions. So you can as well. I will pause the video for a few seconds so that you can, if you want, write down the code and try it on your devices yourself. Mind you, I am using an Android device to run the MATLAB examples here. So you can download the MATLAB app from Google Play, and you can as well write this code and run to see for yourself how the inverse functions look like. So yeah, that's the code, and let us see how it looks like when we run the code. The triangular button here is the one which runs the code. Don't worry about this thing. This basically there are two warnings in here. Neglect those warnings because they are just saying that there are the imaginary parts of complex x and y arguments, the input and output variables. So don't worry about that warning in red color, and we'll just look at the graphs. This is how the arc sine x function looks like for from -1 to +1. I think I gave the range. So -1 to +1, it looks like this. And then the cos inverse arc cos x looks like this. Uh, they're pretty much the opposite way, sine and cos. And then this is the tan x, how the tan x looks like, arc tan x, the inverse function. And then we have the cosecant x, I think, arc cosec x, yeah. And then we have arc secant x, and last at the end we have arc cortex. This is how the arc cortex function looks like. So this is how the um inverse functions look like. So let us now see how the hyperbolic functions look like. So this is the code for hyperbolic functions. I will pause for a minute here so that if you want to write down the code and run it for yourself, you can write down the code. If you write down code for one uh, function, then it's pretty much same, except here the function will change from sine to cos to tan to cosecant. Here is called CSCH here, cosecant hyperbolic, and secant hyperbolic is SECH, that is secant h. Cot is cot h only. The only abnormal notation here is cosecant. Cosecant is denoted by CSCH. So this is the code, and let us run the hyperbolic code, how it looks like. This is the code. This is the sine hyperbolic curve. That is how the sine hyperbolic looks like. This is the cos hyperbolic curve. It's almost like a parabola from uh, mm, 1 to 0 to minus 1, rather minus 1, 0, plus 1. This is how the cos hyperbolic looks like. This is how the tan hyperbolic looks like. Then we have the cosecant hyperbolic. It looks like this. And this is almost pretty much the opposite of cos secant hyperbolic, inverse hyperbola. Um, and then the last one is, of course, the uh, cot hyperbolic. So cot hyperbolic looks like this. So that's I find Matlab very useful, very useful to visualize the functions. So I created this video. Uh, yeah, that's pretty much what I had for you today, as far as Matlab is concerned. So let us meet some other time. Thank you for watching my video.